Have you ever wondered what happens when we step on the clutch pedal? Why do we have to press the clutch when we are going to shift gears? This video will provide the answers summarized in a 3D animation. And at the end of the video, we will know how crucial the clutch function is in a vehicle. Let's start from the following 3D animation. This is an animation of a vehicle's powertrain, consisting of an engine, clutch, and transmission. When we start the engine will rotate. However, the car must remain stationary. And when we put the gear in, the car must remain stationary. The car will only move when we release the clutch slowly. Now, from here, it can be concluded that the clutch's function is to disconnect and connect the engine rotation instantly. Now, understand the following principle. Here I have two discs. The first disc rotates, and the second disc is still. However, when we move the second disc until it touches the first disc, what happens? That's right, the second disc will rotate, according to the rotation of the first disc. This is the principle of how the rotation of the clutch can be channeled. Of course, it's not that simple because there are still many other components that complement it. Now let's go back to the following three-dimensional model. If we disassemble this clutch device, we will find several components. The first is the flywheel. Actually, this flywheel is included in the engine components. However, we include it here because based on the principle we discussed earlier, this flywheel acts as the first disc. Then there is a shaft. This shaft is connected to the transmission input shaft. However, it is not connected to the flywheel, so that the rotation will be separate. Now at the front, this shaft has a gear wheel. This functions so that the shaft can be connected to the next component, namely the clutch disc. Based on the principle we discussed earlier, this clutch disc acts as the second disc. Now because it is connected via the gear to the shaft, its rotation will be related to the transmission input shaft. On both sides of the clutch disc, there are clutch linings. This is the clutch disc friction medium, so that when it comes into contact with the flywheel, there is no spark or slippage. Now, in this position, the rotation of the flywheel is not transmitted. That's because there is a gap between the flywheel and the clutch disc. However, when we apply force to the clutch disc to the front, it will channel its rotation. Now the question is, how do we provide that force? That is the job of the pressure plate and pressure spring. The pressure plate is a solid metal disc that pushes the clutch disc forward, while this spring will hold the pressure plate so that it continues to press the clutch disc forward. So how do you release the rotation? That is the job of the clutch release mechanism. This mechanism consists of a release lever, release bearing, and release fork. When the clutch pedal is depressed, it will pull the release fork. The release fork will push the release bearing forward. The release bearing will push the release lever, and the release lever will lift the pressure plate so that the pressure plate moves backward. Because the pressure plate moves backward, a gap appears between the flywheel and the clutch disc. This will cut off the engine rotation. So that's it. To connect the engine rotation is only done by clamping the clutch disc. It should also be noted the pressure plate, spring, and release lever are connected to the flywheel through the clutch disc cover component. So, the pressure plate and flywheel will always be connected. To disconnect the rotation, just loosen the pressure plate. That will create a gap that makes the engine rotation disconnected. So that's how the clutch works on a car. Hopefully it will increase our insight